Assessing normality. Our objective: use normal probability plots to assess normality using StatCrunch. Well, what is a normal probability plot? It is a graph that plots observed data versus normal scores. What are normal scores? The expected z-score of the data value, assuming that the distribution of the random variable is normal. And here's the kicker right here. If sample data are taken from a population that is normally distributed, a normal probability plot of the observed values versus the expected z-scores will be approximately linear. You will see a line when the data are plotted. Okay, so that's what we're looking for. Now, how do we know? It says approximately linear. It's not going to be precisely linear. It probably will never be exactly a perfectly straight line. That's most likely not going to ever happen with real data. So how do we know if it's linear enough? Is it enough of a line? Is it close enough to a line so that we can say that it's normal? We're going to use this table below. So let me come down to here and we'll talk about this table. Make sure I get it for you. Okay, we're going to use this table to determine what's called a minimum critical value, a minimum correlation statistic. Okay? If the calculated critical value, which StatCrunch is going to do for us, it's called the correlation statistics, is greater than or equal to the critical value below, which is dependent upon the sample size, then we'll say that the data are approximately linear, and therefore the data are taken from a population that is normally distributed. So basically, if our sample size is 15, and we plot our data in StatCrunch and we get a correlation statistic, if that correlation statistic is 0.939 or above, we're going to say it's linear enough, and therefore this data is taken from a population that is normally distributed. If it's less than 0.939, we say it's not linear enough. This data we do not know, but we're going to assume this data is not taken from a population that is normally distributed. Fair amount here, lots of words. I think with StatCrunch and the graph, it'll make things quickly a bit more simple for you. So let's make sure we leave that box up there because we need to make sure we're using these sample size numbers to give us our minimums. And here's our example. The data in StatCrunch 7.3.12 show the number of hours of television watched in a typical week by college students aged 18 to 24. We're going to use StatCrunch, and we're going to do a called a QQ plot, and we want to check both the correlation statistic, because that's what we're looking for, as well as putting the normal quantity quantiles on the y-axis. We're going to check those two boxes, and we're going to use that. We're going to use this graph along with this table to determine if the data could have come from a normal distribution. Okay, so let's take a look. We'll come back to this table in just a moment. Okay, but let's first take a look at StatCrunch and get it in there. So here I am getting ready to open up chapter 7. Section 3, question 12. So there's chapter 7. Section 3, question 12 is here. And here is our data, hours of TV watched. We need to understand the sample size, because if we go back to here, we have to know the sample size. If we go back to here, okay, I'll get it back so it's straight like we're used to it. The sample size is what gives us our minimum critical value. So we have to know the sample size in order to have this work. So let's go back to here. Whoops, sorry about that. And let's check out and make sure we understand our sample size. I'm going to scroll. Okay, our sample size is 25. Here we have 20, our n is 25, and so we're going to look at what the minimum critical value that requires after we calculate it, okay? But we need to know n is 25. Okay, let's calculate this, what's called a QQ plot, or a normal probability plot. And we go to graph, and we go to QQ plot right down here. Of course, they're close to alphabetical order. QQ plot. Select your column. Well, our data is hours of TV. That's pretty simple. Add the correlation statistic and add normal quantiles on the y-axis, and then we can compute. And there is our data, and this is the line that they're saying is the best fit line for this data. Notice this data is not linear. All of these points do not line up on a line. However, are they linear enough? They certainly seem to be in a line as you go from bottom left to top right. Are they linear enough to say that the data comes from a population that is normally distributed? Well, let's look up here at the correlation coefficient that it calculated for us. It tells us that the correlation coefficient is 0.992. Well, if it's linear, it's 1. If they're all exactly on the line, it's 1. This is pretty darn close to 1, 0.992. Okay, so we want to note that number, 0.992. That number needs to be equal to or higher than the number in our table. Let's go back to that. Okay, so let's keep our table here. We know that we have a sample size of 25. Over here, there's our 25 minimum critical value. Okay, it needs to be at least 0.959. Well, our correlation statistic is 0.992. And that is certainly greater than or equal to 959. Okay, so can we determine if this data could have come from a normal distribution? Yes, we can. Because it's greater, this data could have come from a normal distribution. Okay, data taken from a normal distribution. All right, there you have it. That's how you assess normality using a QQ plot. Keep in mind, you need to make sure you know the sample size, because that gives you the minimum critical value. And then you're simply off into StatCrunch. Make sure these two boxes are checked so you can get this. You need to get this statistic out of that, and you'll compare that statistic to the minimum one you need, greater than or equal to, then guess what? It came from a normal distribution.